In an apparently empty region of the sky, far from the brightest stars and the glowing interference of the Milky Way, a telescope points toward what, to human eyes, would be pure darkness. But what appears on its capture is no void. It's a window opened through time. The field of view reveals thousands of overlapping galaxies, like fragments of different eras. Some relatively near, others so ancient that their light began its journey when the universe was still learning to exist. At the center of this colossal cosmic mosaic, a massive cluster of galaxies stands out, compressed by gravity into a single radiant structure. Around it, as if we were seeing reflections in a distorted mirror, appear elongated arcs and faint curvatures of light. Not nebulas, not artifacts, but echoes from the past. Galaxies so distant that their images have been stretched and warped by the cluster's gravity. A phenomenon predicted by Einstein more than a century ago. Gravitational lensing. Each reddish mark, each faint trace, is a signature of an infant universe. A portrait of the first stars igniting the cosmos. And it is exactly this kind of vision that transformed the James Webb Space Telescope into the most powerful time machine humanity has ever built, capable of peering into the very frontier of cosmic origins. To reveal this image, the James Webb remained fixed on the same patch of sky for an astonishing 120 continuous hours. 5 entire days observing a single target without diverting its gaze for even a second. Using its NIRCam infrared camera, the telescope captured 9 separate exposures, each with a distinct filter, precisely calibrated to detect frequencies of light invisible to our eyes. By combining these layers, scientists created a deep composite where each filter reveals a different era of the universe, from relatively young structures to galaxies so primordial that they no longer emit visible light, only infrared. The farther away a galaxy is, the more its light is stretched by the expansion of space, shifting toward longer wavelengths. And it is in this realm, where light becomes faint, cold, and invisible to any optical telescope, that James Webb reigns supreme. To grasp the scale, in just 12 hours of exposure, it surpasses all of Hubble's deepest weeks of observation. At 120 hours, it doesn't just break records, it literally pierces the fabric of cosmic history, reaching an era that, until now, existed only in theoretical equations. And it is precisely this detail that makes this image so powerful. The Abell S1063 cluster, seen at the center, is not just any cluster. It acts as a natural gravitational lens. The combined mass of hundreds of galaxies and a vast amount of dark matter warps the fabric of space-time around it, exactly as Einstein predicted more than 100 years ago. When the light from even more distant galaxies, billions of years older, passes through this curvature, it becomes magnified, stretched, and bent as if traveling through a cosmic lens. The result is these reddish arcs and curved smudges, like ghostly reflections circling the bright core. They are not nebulas. They are not camera artifacts. They are real echoes of galaxies that should not even be visible. Galaxies that existed when the universe was still awakening from its own creation. In some cases, the light we observe began its journey more than 13 billion years ago. Which means that when we look at this image, we are not just seeing far away. We are literally seeing back in time. Webb is not just powerful, it is patient. Unlike any telescope ever built, it doesn't simply photograph the universe, it listens to it. Instead of capturing hundreds of targets per minute, it fixes its gaze on a single point for hours, days, sometimes weeks. Not because it lacks power, but because what it seeks is almost invisible even to the eyes of time itself. It collects light that doesn't shine, light that breathes, so faint it has taken billions of years to cross the absolute silence of space. And yet Webb perceives it. Its infrared vision pierces through cosmic dust, stellar smoke, and even the scars left by ancient explosions. It sees where no other human instrument has ever reached. It sees before light becomes light. And that is exactly why its first discovery deeply shook science's confidence in what we thought we understood. Because Webb didn't just find small, primitive, fragile structures still forming, as theory predicted. What it revealed was something too impossible to ignore. Gigantic, bright, and mature galaxies appearing far too early in the history of the universe. Some of them were already fully formed when the cosmos was less than 300 million years old. An age far too short, according to every accepted model, for something so complex to exist. It's like discovering an entire city built before humanity had even learned to use tools. Nothing matches, nothing makes sense. Either our calculations are wrong, or something accelerated the growth of the universe long before we ever imagined. And in that moment, science, for the first time in decades, was forced to admit perhaps someone or something pressed the fast-forward button. But what truly shocked the scientific community was not just the existence of these galaxies, it was the speed at which they appeared. The James Webb Telescope detected traces of heavy metals within these systems. Elements like oxygen, nitrogen, and even hints of iron, which could not have existed naturally since the Big Bang. They can only be forged inside the cores of massive stars and then scattered through space by colossal explosions. Supernovas. This means that even before the first light we are now observing, stars had already been born, lived, and died, leaving behind recycled material for the next generation of galaxies. What should have taken hundreds of millions, perhaps even billions of years, happened almost instantly. And that raises a question that lands like a bomb on the desks of cosmologists. Was the universe always this fast, or was it artificially accelerated in its earliest moments? If the universe began already organized, coordinated, and fertile, then maybe we're not witnessing creation, but rather the continuation of something that was already set in motion. And this is where things stop being merely surprising and start becoming uncomfortable. Because the more data Webb sends, the clearer it becomes that the universe didn't just evolve quickly. It evolved in order. Galaxies that should be chaotic and fragmented appear with stable disks, coherent rotation, symmetrical formations, as if someone had sketched the structures before they existed. There are patterns that resemble rhythms, precise cycles, natural gravitational harmonies, almost as if the cosmos follows laws that leave no room for absolute randomness. What was once distant speculation is now taking real shape. These structures don't just exist, they appear optimized. And Webb is showing that this isn't rare. It's finding multiple impossible galaxies emerging too early, too large, too precise. And worse, this isn't just the past. Some of these formations are still active right now, in real time, emitting signals that fluctuate and vibrate, as if something were transmitting, not merely existing. And that's why the next phase of the James Webb mission is so critical, because the question is no longer what exists out there, but what is still happening at this very moment. If these galaxies didn't just emerge too early but remain active, emitting patterns, variations, and fluctuations that seem to follow extremely coordinated natural codes, then we stand at the edge of one of the greatest revisions in astrophysical history. Current models may not just be incomplete, they might be looking in the wrong direction. For the first time, science is seriously considering that it's not enough to observe the universe. We must listen to it, because there's a real possibility that these structures are not relics, but systems still in operation. And if that's true, the next data from Webb won't reveal the past of the universe. They will reveal its engineering. What did you think of the video? Leave your opinion in the comments, and don't forget to subscribe and leave your like.